Hi, my name is Garrett Goossens,
And I'm Natalia Fuentes.
and today we're going to be presenting on techniques for studying the Florida bonneted bat, Eumops floridanus. The Florida bonneted bat is an endangered species in the family Melocidae, endemic to a small range in South Florida. This species is notorious for its small, elusive roosts and high-flying nature. However, these unique traits of the Florida bonneted bat, in conjunction with the limitations of survey techniques, makes it extremely difficult to gain comprehensive data crucial to its conservation. Through this project, we aim to assess the efficacy of methods used to study Florida bonneted bats and explored ways to improve upon current techniques. Acoustic surveys take advantage of the high-frequency calls emitted by echolocation to track the movement of bats. Acoustic surveys allow for inference in home ranges, roost locations, and behaviors. To start, acoustic methods are passive techniques that reduce risks of direct harm to bats and minimize risks of disease transmission between researchers and bats. It is also less labor-intensive. Florida bonneted bats have a unique echolocation call that is easily distinguished from other South Florida bat species. This call is at an exceptionally low frequency, in fact the lowest frequency of any Florida bat species. This makes it audible to some humans, so well-trained researchers can distinguish sounds without the aid of equipment. In a 2016 study by Bonneted et al., researchers who were able to hear Florida bonneted bat calls were trained to identify and document their detections, while researchers who could not hear the bats were aided with handheld ultrasonic detectors. In this same study, acoustic surveys were used to identify areas of high-flying activity of Florida bonneted bats. This information could be used to identify new roosts, especially when combined with human observers. In 2017, another study by Bonneted et al. Used recordings of bonneted bat calls as lures for mist netting. This study showed that these recordings can be extremely effective and improve the efficacy of mist netting. However, there are also some drawbacks to acoustic surveys. The equipment cost of acoustic surveys can pose as a barrier in researching bonneted bats. According to Garrett et al., Florida bonneted bats fly fast and travel long distances, making the placement of acoustic devices more difficult. The use of many devices over a large area may be necessary for an effective acoustic study. This would not be only more difficult for the researchers, but it would increase the monetary investment needed for a study. Hands-off techniques like acoustic surveys don't allow for the measurement of any physiological data or collect any genetic information as well. Acoustic surveys also do not allow for population estimates since you cannot identify individuals in a recording. For population-level data, different techniques must be used.
Another common method used for studying Florida bonneted bats is mist netting. Mist netting is a common method for surveying bird species, but is also frequently applied to bats. The process of mist netting involves directing a large fine mesh net across the flight path of an animal with the intent of intercepting it. Researchers can then extract animals from the net to take measurements, mark or tag, and record data. Through mist netting, researchers are able to more accurately estimate population sizes. The ability to physically capture bats also allows for the tagging of individuals, which will aid in researchers' ability to identify them. Additionally, tagging can be an effective method for discovering new Florida bonneted bat roosts with the use of radiotelemetry. Capture of live animals allows for the collection of certain data that could not be collected otherwise, such as physical measurements and genetic information. As previously mentioned by Bonneted in a 2017 study, acoustic lures increase the capture rate of bats in mist nets, making this method effective for Florida bonneted bats. Also, mist netting tends to be a relatively inexpensive method of capture. Unfortunately, mist netting also presents some challenges. Since it is an active capture method, mist netting requires careful, consistent attention from researchers and causes stress for the bats. The process of erecting heavy nets may also be labor-intensive. Florida bonneted bats are an endangered species that are also at risk of disease transmission, and so a lot of time is needed for training and acquiring permits to work with this species. As Ober et al. Explains in their 2016 study, since Florida bonneted bats are a high-flying species, it can be difficult to place a mist net in the flight paths of these bats. In the same vein, nets in an open area can easily be seen and avoided by Florida bonneted bats. Thus, mist netting can prove to be challenging when not being employed near known roost sites or aided with an acoustic lure. Unfortunately, despite its ability to increase capture rates, the use of acoustic lures with mist netting may result in biased samples that cannot be used for population-level data. There is no simple solution to surveying Florida bonneted bats. Methods should be chosen based on the type of data required for research. We recommend the use of acoustic surveys when possible. This method is especially effective due to the distinctive call of Florida bonneted bats. Acoustic surveys allow for inference in home ranges, occurrence, and behavior. This information could be used to identify new roosts, especially when combined with human observers. When physiological data or tagging is needed, misnetting may be required. For this method to be effective, we recommend the use of acoustic lures in conjunction with the misnet or strategic placement of the net near a roost site. However, acoustic lures may result in sampling bias and so should not be used for population-level data. In such cases, nets should only be placed near a roost site. This may be difficult because of the small number of known roosts. However, location of new roost sites is most plausible with the use of acoustic surveys and/or tagging made possible by capture with acoustic lures.